This video is on trigonometry and how to use the trig ratios when working with right angle triangles. So we have a right angle triangle here, and one of the angles is marked and we're calling it theta, and then the opposite side is here, so the opposite this angle theta, and then the adjacent side to the angle theta, and then this is the hypotenuse. The hypotenuse is the longest length and it's also opposite the right angle. Now when we have these triangles, we know that sine theta is equal to the length of the opposite side divided by the length of the hypotenuse. Cos theta is equal to the length of the adjacent side over the length of the hypotenuse, and tan theta is equal to the length of the opposite side over the length of the adjacent side. So when we're working with right angle triangles like this, usually the problems are find either the angle or one of the sides. So either this angle or one of the sides, maybe that angle. And then if you're given this angle, then you'd have to label them differently as well. So you have to label your new opposite side and adjacent side, and the hypotenuse will stay the same. Now, one of these things, so either the angle or these two sides, or the angle or these two sides, or this angle or these two sides, will be what you're trying to find, and the other two should be given to you. So let's try and answer some of these questions. So in this first question, I have a right angle triangle. I can see that the hypotenuse is this length here, which is 5, because that's opposite the right angle, and I have my theta, which I'm going to need to find, and I have the opposite side to theta. So I've got opposite, and I've got the hypotenuse, and I've got this angle. So when working with the opposite and the hypotenuse, I can see that that's going to be sine theta. So sine theta is equal to 2 over 5 here. So I'll write that down. Sine theta is equal to 2 over 5. Now, how do I find theta? Now, in this type of question, when you're trying to find an angle, it's best to think of this as an operation on theta, and we need to do the opposite operation of that, so that we just have theta on this side, and we need to do it to that side as well to keep it balanced. So we're going to have theta equals the inverse of sine, and then 2 over 5. And then this is when you're going to need to use your calculators. So put this into your calculators, and I've done this, and the answer is theta is equal to 23.578178, and so on. And if you're rounding it to one decimal place, let's say, it's going to be 23.6. So let's look at this next one. This time the angle is given, and I'm working with the opposite side and the adjacent side. So this one was tan, because tan theta, or tan of this angle, is this length divided by that length. So let's write that down. So I have tan 42 is equal to x divided by 3. So if I want to find the length of this side, I'm going to multiply both sides by 3, so that I have x is equal to something. So I'm going to have 3 times tan 42 is equal to x. And then this is when you get your calculator out and put this into your calculator. Now your calculator might start a bracket here, and if it does, it's always best to close this bracket, because when you get into the habit of not closing this bracket, when you're working with fractions and dividing and things like that, you might get an error. So it's best practice to always close this bracket into your calculator. So close that bracket, put that into your calculator, and you should get x is equal to 2.701212, and so on. And this to one decimal place would be x is equal to 2.7. So this length here is 2.7 to one decimal place. Now one more question. So we've got the right angle there. This is the hypotenuse, because this is opposite the right angle, and this is my angle, and I'm working with the adjacent side and the hypotenuse. So I need to use cos of the angle. So I've got cos of 25 is equal to 7 divided by y. Now it's best to think of this whole thing here, the cos 25, as a number. So this is a number, and it's most of the time this is going to be a long decimal number. So if we keep it as cos 25 for now, it helps us try and solve this equation. Now I need to find y, so I don't want that at the bottom of a fraction, so I'm going to multiply both sides by y. So I'm going to have y times cos 25 is equal to 7. Now if I divide both sides by cos 25, I'm going to get y is equal to 7 over cos 25. And then this is when you would use your calculator. So put this into your calculator, and again, if your calculator does open a bracket here, make sure you're closing it there as well, and put that into your calculator, see what you get, and you should get 7.72365 and so on, and to one decimal place this would be 7.7. so this length here would be 7.7 to one decimal place. Now I'd like you to think, now we can see that this is sine, this is tan, and this is cos, and that's one of the differences between the questions. Now I'd like you to think, what are the other differences in these three questions? Okay, so they're all different, not just because the sine, tan, and the cos, but other reasons why these questions are different. Okay, and also I'd like you to answer these questions. So there's 4 questions for you to do. Answer these questions and then bring that to the lesson.